Good afternoon, ladies and gentlemen, Minister and the organizer. Thank you very much that you invited us to share some ideas about a practical aspect of this topic of stormwater management. First of all, my name is Gruenig, and I am responsible in our company for the international projects. First of all, just allow me to introduce our company, where we come from, and what we are doing, before I step into these practical aspects. HST is a German middle-sized company established in 1981, and we're doing design and manufacturing of technical and operational equipment for systems and objects for the water infrastructure, and doing also software for operational organizations. What is the right button? Okay. So we're doing mechanical equipment, automatic operational wares for water level control, CSO fine screens, and as well as operational software, process control software, SCADA systems. We're doing operational software for the to organize workflows and asset management for water companies, operation organizations, and we're also doing measuring systems, engineering, and data collecting and evaluation. So this is a little bit unique that this mechanical equipment as well as the software comes out of one company. So now the global challenges. As we heard already, water infrastructure nowadays facing various global challenges. Looking at urban stormwater infrastructure, these challenges are mainly rising urbanization, and secondly, increased frequency of extreme weather events due to the climate change. The impact is urban flooding. This can be experienced day by day around the world. Urban flooding is, to a large extent, an immediate impact of the overloading drainage system. This is a result of increased sealed areas in our growing cities. Another impact is the pollution of the receiving water bodies. Of our receiving water bodies. Stormwater is responsible for about 50% of the pollution flowing into the receiving waters from the CSO points, mainly from combined sewer system in the rain event. And they contribute a lot to the pollution of our lakes and the rivers. So, what to do? Managing fluctuations. If you look at a city, as an infrastructure of a city, fluctuations are the nature of every infrastructure and power. The cause of the fluctuations are the timely changing needs, and hence the more or less predictable maximas and minimas. Concerning the drainage systems, the dimensioning of the infrastructure, considering just the maximums, is usually not practical. Unfortunately, we don't have pipes and channels that can expand depending on the hydraulic load. This would be a nice invention anyway. The solution is to balance the fluctuations through creating storage capacity. And that is what we heard already a lot this morning. But the second aspect is to manage it well. Yes, to manage it, to make the best use of the existing storage volume. That means to create the retention volume is not enough. We need to manage the drainage infrastructure most intelligently, meaning to manage the system in the most effective way. And how to do this? Nowadays we have a lot of data available in an infrastructure. A water infrastructure consisting of many objects. These are rainwater retention tanks, these are wastewater treatment plants, these are the sewer and sewer network, pumping stations, and so on and so on. All objects, more or less, depending on each other and have some kind of influence to each other. And to exchange information about the status and the condition of these objects would be an extremely useful effort. Actually, the actual water level available, how much storage is available, in which status the wastewater treatment plant is in operation. So this would be a valuable source of information. And a lot of this information we have already. We heard this from previous speakers, especially also here in Gdansk. That means we need to connect this available information in a smart way. So to manage complex stormwater systems, the precipitation data are extremely useful. To know when, where, and how much rain is going to fall is a crucial information. Additional information about the rainfall trend and the development covering the next hours is very important. So our company, HST, has developed the first professional digital rainfall portal that is called NIRA-Web for the water industry. So the data are provided by government-run meteorological organizations using radar stations and they are all calibrated by physical stations. Here, for example, there is an example of the city of Oberhausen, where you can see the different areas to be monitored and forecasted the rainfall. So it's a very high density and resolution of rainfall, right? The rainfall portal provides the actual data, the forecasted data for 6, 12 up to maximum 72 hours, and the historical data for scientific purposes. The precipitation data are available in a high resolution, in a graphical resolution of about 1 square kilometer, as well as in a timely sequences of 5 minutes. And this availability, the availability is in digital format to feed directly into software programs or in simulation and process control systems. The data are especially tuned for the water industry and used by planners for planning and design purposes, or for scientists, but also for the operators to control and to manage the monitoring the infrastructure. Here now I want to show you an example what we have been doing now that is in progress. That here you see the simplified schematics of the drainage system of Erfurt, a middle-sized German city. And the goal was to design a management concept, a management strategy to reduce the CSO overflows and the urban flood risk without constructing additional retention tanks. And that is a problem that Mr. Volkowski also mentioned before. There's not always the space for it. So to do this, here the slide shows these river. Here these are the sewer channels and rainwater retention tanks, all of them. And to achieve this, these retention tanks has been equipped with level and flow control devices that are dynamically controlled by a higher level process software. That means the actual condition in the entire system and the objects and the condition of the receiving water bodies, rainfall forecast, etc., will be measured and continuously monitored by sensors. Then these digital data are transmitted into a in real time to IntelliNet, that is a management system. And this IntelliNet software, it's a SCADA plus flow simulation software evaluating the situation. The actual data, storage capacity, treatment capacity of the treatment plants and so on, and compares these data with the hydraulic load and the CLDO load to be expected to enter the system within the next couple of hours, up to maximum 72 hours. And then these mathematical algorithm calculating a most favorable operating strategy. Yeah, that means from a higher level SCADA system, transmit these calculated signals to the control devices. Yeah? That means, in other words, then the system decides which control devices needs to be open or closed, or maybe move some volumes from storage tank into another area because there is less rainfall to be expected. So to manage and to guide these capacities. Another example that has been in progress now is a city in China that we have been doing, Jinan. And this is a system consisting of 8 rainwater retention tanks, and they are all connected to the IntelliNet software and equipped with sensors to monitor and to generate the digital data. And they're talking to each other. That means if some of these retention tanks are full and there's more rain to come, they are able to move this into other areas, into other sections of the city to make space for the rain to come within the next hours. So that is a growing system. That is now the first step, is just to connect the rainwater retention tanks. And the second phase, there will be extension to integrate also pumping stations and other wastewater treatment plants and so on. So as other speakers before already mentioned, this is a growing system that gradually needs to be extended. So to do this and to use this data, this digital data, we need, of course, equipment that are able to make use of the data. That means we need intelligent flow control devices. We need intelligent tank cleaning systems or solid retaining screens. And we add to these mechanical devices a so-called software, IntelliFlow, IntelliGrid, IntelliScreen, to be able to be adapted and adjusted to the real actual condition. So here you see an overall picture how this system looks like. So it is consisting of the rainwater platform, the IntelliNet software, and then the intelligent devices. They are like flow control, automatic operating wares, and so on, that sits in these objects. Yeah? And as an additional option, it is also possible to connect the process control system, the SCADA system, with an operational software that organizes the workflows and triggers special activities, service teams, and so on, whatever, according to the actual situation. So that means specific preset activities for the work staff will be triggered. Additionally, automatically reports and analyses will be generated for the higher management level. So here you see this is a complete system. You have everything can be seen on one and the same screen. There are the visual monitoring by cameras. GIS data using to have the total overview of the complete city, and then the NIRA web rainfall portal, as well as graphs and tables to analyze and to document the actual situation. Okay, so this was very, very briefly about the practical aspect of the of a rainwater management system. And I think here in Gdansk, at least, the first step has been done to install all these sensors in the system. Now the second should be naturally to make use it for a practical use, to create more reliable operation for reduced investment because of using the storage capacity in the best way, and to optimize assets performance. So thank you very much for your attention.